Hello and welcome. This is Bhaskar Napte from Pharma Growth Hub, and in today's video we are going to talk about the ReDIET formula. Yes, now this is the formula which I have coined in understanding the lab data accuracy during the investigation. Now, this is very important questions, and in case if you are preparing for recent interviews, in case if you are going to attend the interviews related to the quality management system, and very specifically about the out of specification, then this video is certainly going to help you. So sometimes out of the nervousness, we may forget few of the very important terms. And if you do not talk about those important terms during answering the questions, the credibility cannot be built. So to help you out, making sure that you remember each and every term during answering this question, this video will certainly going to help you. So I will explain what is the meaning of this re-diet F, and I'm sure this re-diet F word is very easy to remember. And once you remember this re-diet F word, you will be able to answer the question on how to identify the assignable root cause. Now, if you look at the US FDA or the EMA guideline published for investigating the out of specification, US FDA has not given the phase 1A and phase 1B investigation, but EMA has further divided phase 1 investigation into phase 1A and phase 1B investigation. So what is the purpose of carrying out the phase 1A investigation? To identify the obvious error. The obvious error is the error which you can easily identify and detect during your very primary investigation. To give some examples of obvious error is calculation error. Will you be able to detect calculation error just by checking the calculation formula? Absolutely. Can you able to detect the error during preparation of the HPLC instrument method? You can easily check the instrument parameters and you can detect it very obviously. Will you be able to detect any kind of errors um, during handling of the sample preparation? Probably not. Will you be able to detect error during the sonication? Will you be able to detect any kind of error during the filtration? Now, these errors may not be possible to detect with a primary investigation. So to understand whether the filtration was the issue, whether the sonication was not happened properly, whether the dilution was not done accurately, you need to conduct some kind of experiments, and then you will understand and identify the errors based on to the lab investigation. So these errors are classified as the assignable cause. So to understand the assignable cause, you may have to conduct the lab investigation or experiments. I hope you understand the difference between obvious error and the assignable error. Now the next important point is during this discussion, interviewer may ask you, I understand how you are going to detect the obvious error, but please let me know how you are going to understand the assignable cause. And this question can be answered with the ReDIET formula. So to understand the lab data accuracy, LDA equal to ReDIET F. Now this is the equation, and you are going to prove whether the lab data during the original analysis was correct or it was not correct. Let me explain you the ReDIET F formula. And here is the term DIE, T and F. So what is the D stands for? The D stands for the dilution, and the re word is already available there. So re dilution is the first term. So how you can investigate the assignable cause in case if you are finding that The dilution could be the reason, or the incomplete transfer of stock solution is the reason. Redilution is the experiment you need to conduct. So you understand that, okay, I must talk about the redilution during answering this question. The second term stands for I. So what is the I now? The I stands for injection, and so there is a re-injection. So in case if you are conducting HPLC or gas chromatography analysis, so in what situation the re-injection needs to be considered? When there is a transient equipment malfunction. If you suspect the transient equipment malfunction, for example, the injected volume was not accurate because of the air bubble present into a syringe. So, in case of such kind of observations, such kind of hypothesis, you can conduct the re-injection. In case if you found that the HPLC vial was not properly capped, the septa was slipped, and because of that probably the injection was not happen appropriately, and hence the re-injection becomes the experiment which may help you out in understanding whether the septa was not really appropriately kept or not. The third term is E. So what is the E stands for here? The E stands for the extraction or the re-extraction. So in what situation you will consider the re-extraction? Look at here. The poor extraction or equipment malfunction is expected. So if you think that probably the sonication was not done properly, if you think that the sample solution was not sonicated up to the designated time, if you feel that the sonicator was not performing well, during that time you can always think of the re-extraction. So you can take the same solution available, the original stock solution of your sample, and you can re-extract it. You can resonicate it and then understand whether there is any increment into the result is found. For example, increase into the assay value. So this is the third term that you must not forget to mention. The fourth term is what? T. So what is the T stands for? The T stands for the test, and the T stands for the retest. So when you are going to consider the retesting of the sample solution during the phase 1B investigation. See, I would like to make a very important point for sure that the retesting is generally not allowed as a part of phase 1B investigation. You cannot just prepare the sample one more time and understand whether the result is meeting the spec or not. But what are the circumstances under which you will be allowed for the retesting? The circumstance number one, if your solution itself is unstable and it has crossed the validity period, so it cannot be used for the analysis. The second point, the wrong stock solution was prepared. So you have a preparation of the sample solution, the stock is prepared, and further the 10 ml of the stock solution is diluted to 100 ml. Now the result is wrong. The reason is why your preparation of the stock solution itself is wrong. So in spite of having the good validity, the stability of your stock solution, you will not be able to use that. Why? Because maybe the preparation of stock solution is wrong due to the measuring the wrong sample quantity. The third one, stock with non-homogeneous sample. So you prepared this, you taken the right sample weight, you have taken the right volumetric flask, but you identified that the sample itself was not homogeneous. And in case if the sample was not homogeneous, you cannot really expect the accurate result. So it is not your fault, but it is the fault of the sample property which is non-homogeneous. So in case if the sample is not homogeneous, you have every right to prepare the stock solution one more time by having the homogeneous by having the homogeneous test solution, by mixing it properly, by grinding it properly, and then you make another stock solution. So this is called as the retesting. The fourth point, when the retesting can be allowed, the flask used for stock is contaminated. If you prove that yes, the flask used originally preparation of the stock solution itself was contaminated, then there is no point and meaning in investigating the further analytical solutions, right? So you need to first correct the stock solutions. Now how you are going to correct the stock solution? Unless and until you prepare another stock solution, you will never be able to understand that yes, the earlier solution was really contaminated because of the flask solution, because of the flask that you have used. And the last but not the least, the fifth one, use of wrong chemicals or stock preparation. So if you find that the reagents or chemical used for preparation of the original stock solution was actually a faulty, in that situation you are allowed to make the another stock solution from the original test sample. And this is called as the retesting. But remember, the retesting result cannot be replaced, or your original result cannot be replaced by retesting a result. The F stands for the filtration, so refiltration. So in case if you are doubting that the filter paper or the filtration technique, filtration process or the filter paper used is wrong, you suspect, you doubt onto the filtration process, in that case you can refiltrate the stock solution available or your test solution available with the right filtration technique, with the right filter paper, and then understand whether the result is within the spec or the result are not yet within the spec. So these are the analytical experiments you can easily conduct to understand the laboratory data accuracy, to understand the assignable cause. This ReDIET formula can certainly help out. And this is very easy to remember. The diet word is very common and we all use it every day. So ReDIET, remember the ReDIET term, and I'm sure that you will be able to answer these very important questions on how to identify the assignable cause. What experiments you can conduct to assign the what experiment you can conduct to identify the assignable cause. I hope you must have got a good idea about answering these questions. Thank you so much for watching this video.